So the third thing we did in this morning's meeting, this is April 20th, was talk a little bit about energy change and chemical reactions. So what I did there was write a chemical equation down. It's one that we've done in class. This was the balloon reaction where we made the hydrogen-filled balloons and exploded them on the ceiling. Drawing pictures of these molecules, you've got a hydrogen bonded to a hydrogen, but there are two of them. You have an oxygen bonded to an oxygen. From first semester, you remember how to draw dot diagrams, and so add the valence electrons, etc., etc. And then over here we have two water molecules. They look like this. Two bent molecules. Okay, so what we talked about was how many bonds had to be broken, how many bonds had to be formed in order for this reaction to happen as it's written. So broken would be 3 bonds. And formed bonds would be 1, 2, 3, 4. Okay, breaking bonds requires energy. Forming bonds releases energy. Okay, so in this reaction, do you remember that there was a big explosion over here? It went boom. So there was more energy that came out than we put in. So if you have more energy out than in, we call that an exothermic reaction. Exothermic. Energy goes out. There's a net release of energy. So that means kind of like if you have a system here, a closed circle of stuff, and energy is released, energy flows out of that system. That's exothermic. On the other hand, if you had more energy go in than come out, and this reaction was more out than in, energy in. So if there's a net energy in other words, if we have the system where energy is flowing into the system, we call that endothermic. So 2 key words. Exothermic means energy out. Endothermic means energy in. An example of this that you might remember of endothermic reaction, one day I had a series of test tubes set up like this. I had a balloon sitting on top of the test tube. I put some baking soda in a balloon, put the baking soda down into this acid, and the balloon got bigger. Here, make a bigger balloon. There you go, like that. And I had some of you feel the test tube. The test tube felt cold. That would be energy going in because the test tube is losing energy to the chemical reaction. Energy is flowing into the reaction. So the circle here would be the reaction. Energy flows in. The environment gets colder, and that would be the test tube. That's why it felt cold. It's also why you feel cold when you step out of the shower in the morning, because water evaporates off of you and molecules have to move faster. So it takes energy to do that, and the energy comes from your body, so your body feels cool. All right, now 2 graphs we have to show these reactions. One graph looks like this, the other like this. This is, I'm going to call it stored energy. It's actually called enthalpy. Enthalpy. I'll write that word up here. And the other graph, same, stored energy on the y-axis. This is time as the reaction proceeds. So chemical reaction proceeds. Which reaction has an overall loss of energy where you end up with less stored energy than you did at the beginning? So that would be this one. So since you have less stored energy, that means that energy got transferred into something you could see. And so that would be like this one up here where we have the explosion and the heat is released. So if I can change the size of my video slightly. I can go old school, raise it up a little bit. There we go. Okay, so now we can see the whole piece of paper, perhaps, almost anyway. So which one of these two graphs would represent this kind of reaction where energy is released? It would be this one. Because you end with less energy stored than you did at the beginning. So you have a net loss of energy. Here, this one is endothermic. You're ending with more energy than you started. So here's your end. This is your start. These are called the products. These are the reactants. This is the products. These are the reactants. So you end with more than you started. That's endothermic. If you end with less than you started, that's exothermic. In this kind of reaction, you will notice the heat released, like the fire in the balloon. And in this one, you'll notice heat absorbed. And what that means is that whatever you're touching will get colder. Okay, heat absorbed. So notice heat released on this one, and you'll notice the heat's absorbed over here, it gets cold. All right, one other thing. There's an energy right here called activation energy. Over here, it's right there. Activation energy. The best place you can relate to this is when you strike a match. You know, you have to put in, the match burns once it starts burning, but you have to put energy into it to get to start. That's called the activation energy. And then while the reaction is proceeding, the energy is released. So you get this is the reaction profile for a burning match. You'll end up with less energy than you started. But it does take some energy to get it started. Same thing is true over here, except you don't get back as much as you put in. You have to put in a lot. So the actual energy change, which I'm going to call delta H, which is change in enthalpy, represented by H usually. So delta H from here to here, that's the change in heat. Over here, delta H is here. So the sign for delta H here would be a negative delta H on the exothermic because energy is being lost. Over here, you'll have a positive delta H because energy is being put into the process. That's called endothermic. All right, so that's a little brief overview. I'm going to put some questions up about this, and I'd like for you to try the quiz after you've watched this video.